This video discusses modernizing an electrical system with added safety, transitioning to microprocessor-based protection, and IEC 61439 compliance for zero electrocution risk. Current challenges in electrical safety include the reliance on thermal-magnetic MCCBs in present low-tension systems. Their performance is affected by temperature, aging, and wear, leading to delayed and non-precise responses to faults. The solution is microprocessor-based MCCBs, which replace mechanical sensing with digital protection. These offer true RMS measurement, high accuracy, stable performance, and instantaneous selective tripping. They also provide programmable and integrated ground fault protection. Earth leakage protection is crucial because insulation failure can cause leakage to metal bodies. Leakage above 30 milliamperes can be fatal. A 30 milliamperes instantaneous tripping standard using a CBCT with an earth leakage relay prevents electrocution in public installations. For LT panels, we recommend using microprocessor MCCBs and ensuring compliance with IEC 61439. Features should include PCHMI communication, power quality and event logging, and adjustable earth leakage protection. To protect the last mile, RCBOs are mandatory at the sub-distribution board incomer and in areas like lighting poles, public areas, and staff quarters. RCBOs provide overload, short circuit, and earth leakage protection with 30 milliamperes sensitivity for human safety. Additional safety measures include using RCC Hume pipe for cable protection and route markers to prevent excavation damage. We also recommend PRCD for geysers and wet areas, and AFDDs to prevent arc fires. A busbar trunking system is an alternative to conventional cables used for distributing large currents in substations, LT panels, workshops, and railway platform lighting and power circuits. Main components of a busbar trunking system include copper or aluminum conductors, insulation sleeves, GI or aluminum enclosures, jointing kits, tap-off boxes, end feed units, and expansion joints. Busbar trunking offers several advantages over cables, such as higher current carrying capacity, better heat dissipation, low voltage drop, compact installation, and a fire-resistant metallic enclosure. They are also easy to extend and maintain and have a longer life. PIR, or passive infrared, sensors are widely used in lighting systems for energy conservation. They switch lights on when human presence is detected and turn them off when the area becomes vacant, avoiding electricity wastage in various public and private spaces. PIR sensors detect changes in infrared radiation emitted by the human body. When movement is sensed, a signal switches on the lights. After a preset delay with no movement, the lights are automatically switched off or dimmed. Maintenance-free earthing, or MFE, provides long-lasting, low-resistance grounding without the frequent maintenance of conventional systems. Earthing ensures a low-resistance path for leakage or fault current to complete the circuit via earth to the transformer. The MFE system uses primary and secondary MS pipes as conductors, each 3,000 millimeters in length, and a conductive mixture. The electrode is designed to have a current carrying capacity of 40 kiloamperes for 1 second. ABLDC, or brushless direct current, fan utilizes an electronic motor instead of a traditional induction motor. It lacks carbon brushes and uses an electronic controller to rotate the motor. BLDC fans offer significant energy savings of about 57%, which can translate to approximately 1,100 rupees in electricity cost savings per fan per year, with a payback period of about 2 years. To conclude, save human lives and prevent damage by adopting microprocessor MCCBs, implementing 30 milliamperes RCBOs, using smart monitoring and AFDDs, and employing busbar trunking, PIR sensors, MFE, and BLDC fans. Our motto is no loss of life due to electrocution.